Okay, so we are going to be classifying triangles, and there are two ways to classify triangles. You can classify triangles by angles, or you can classify triangles by their sides. So if we're classifying triangles by angles, we have acute, which means all angles are less than 90 degrees. We have right, which means that you have one right angle. You have obtuse, which means that you have one angle greater than, I'll put the sign in here, greater than 90 degrees and less than 180 degrees. And then you have one that is not honestly used very often, but it's called equiangular. And that means all angles have the same measure. So let's think about that one for a minute. If all angles have the same measure, we have 180 degrees in any triangle. Divide that by the three angles because they all have to be the same. So that means in an equiangular triangle, every angle is 60 degrees. So that's what you have if you are classifying by angles. If you are classifying by sides, we have a scalene, which means that you have no congruent sides. So you might see something that looks like that, or definitely three different side lengths. Then we have, I'm going to jump to equilateral, which means that all sides are congruent. And that would look like something like that. So notice all the tick marks are exactly the same. So if I know that this is 4 centimeters, then I can fill in all the other ones of 4 as well. Then we have what is called an isosceles. I know in the past, an isosceles, typically you think of has 2 congruent sides, but actually it is 2 or 3 congruent sides. The reason why it expands to 3 is because all the properties of an isosceles also work in an equilateral. Okay, so typically we think of, I think of like the witch's hat. So we have 2 congruent sides. We also learned previously that if the 2 sides are congruent, then the angles opposite were also congruent. Okay, so that is what we have if we are classifying. So in order to classify by angles, you have to have the angle measure or be able to find all 3 angle measures. In order to classify by sides, you have to be able to find the side lengths. So let's do a couple of review problems of those. So for example 1, and do not look at scale, you cannot be assuming. So if we're going to classify by sides and angles. So if I know that I have just those tick marks, then I know that I can classify by sides. There are no sides congruent, so I know it's definitely a scalene. And in order to classify by angles, I have to be able to find the angle measures. So let's say that this is 102 and this is 43. So you can't just look at those, you have to look at also the missing ones. So I'm going to use my calculator. That is not big. And so the missing angle is 35. So because I have an angle of 35, 43, and 102, I have to look at, usually we look at the biggest one. It's not 90, so it's not a right angle. It is greater than 90, so this means that this is going to be angles. This is going to be an obtuse. Example 2. Okay, so if we have, we're classifying this by sides, I can look at the tick marks and know that these are going to be congruent, so this is going to make this an isosceles. Angles, I am going to find my other angles. So I know that this is 100, so that means these two have to add up to 80, which means that each of these is 40. Again, we're looking at this angle. It is greater than 90, so this is also an obtuse. Something you may have to do, just kind of refresh your memory, and I'm not going to actually complete this example. Let's say that we have triangle DEF, and point D is at this ordered pair. Point E is at that ordered pair, and point F is at that ordered pair. Okay? And we are looking at classifying by sides. So what I would do is I would draw a figure. I'm not going to bother to graph. Honestly, I don't really care. D, E, and F. D is at 4, 3. E is at negative 5, 1. F is at 7 and negative 8. So in order to classify this by sides, I have to find the length of the side. So that means I'm going to have to use the distance formula for DE, the distance formula for EF, and the distance formula for DF, so I can actually find the length. So I'm going to go ahead and do this on my calculator. So I'm looking for the distance of DE. Remember the formula, x sub 1 minus x sub 2 squared plus y sub 1 minus y sub 2 squared. I'm going to take a shortcut. So I get DE to be the square root of 85, which gives me about 9.2. The distance of FE, again, I'm going to take a shortcut. Chuck it in my calculator. You get a nice, neat square root of 225, which gives me 15. And then the distance of DF, get the square root of 130, which is approximately 11.4. So then I'm going to look at my lengths. I have a length of 9.2, 15, and 11.4. None of the sides are equal, so this is going to be a scalene triangle based off of the sides. Okay, so review that distance formula.